There we go. So today we are going to talk about Netflix architecture. So today we are going to architect Netflix live in the stream. So we are going to see how Netflix actually operates. So that's what we are going to do now. So let me know if I'm audible. Today we are going to architect Netflix live in the stream. Okay. So we are going to see how Netflix actually operates. So that's what we are going to do now. So let me know if I'm audible. Today we are going to architect Netflix live in the stream. Okay. So we are going to see how Netflix actually operates. So that's what we are going to do now. So let me know if I'm audible. Today we are going to architect Netflix live in the stream. Okay. So we are going to see how Netflix actually operates. So that's what we are going to do now. So let me know if I'm audible. Today we are going to architect Netflix live in the stream. Okay. So we are going to see how Netflix actually operates. So that's what we are going to do now. So let me know if I'm audible. Today we are going to architect Netflix live in the stream. So we are going to see how Netflix actually operates. So that's what we are going to do now. So let me know if I'm audible. Hello. Hello. I hope you're able to hear me now. So let me know if you're able to hear me. If not, probably I will check what the problem is. So I have changed my setup to make it a bit more better. Hear me now. So that's let why me know if you are able might to have some sort of problems. If not, probably I will check what the problem is. So I have changed my setup to make it a bit more better. Hear me now. So that's let why me know if you are able might to have some sort of problems. If not, probably I will check what the problem is. So I have changed my setup to make it a bit more better. So is my audio clear? You might have some sort of problems. If not, probably check what the problem is. So I have changed my setup to make it a bit more better. So is my audio clear? Okay, looks like the audio is not coming back. I mean, there's a bad audio. Hello. Hello. Okay, maybe I have to go about using my desktop as the main device. Okay, I hope this is audible. Okay, so maybe I have to avoid this mic and stream directly from. Uh, just a moment. I'm just fixing my mic so that we can get started off. So, okay, there we go. Okay, so today we are going to talk about Netflix. So if I am loud, let me know. So probably I will reduce the volume, mic volume. So anyways, so today we are going to architect Netflix live in the stream. So that's what we are going to do. So it has been quite some time since we talked about architecture from various companies, various organizations, and today we are going to talk about Netflix. The reason being, so Netflix is a really engineering-driven organization. So it's basically bleeding edge. It serves a lot of people, millions of people around the world, and it serves a lot of content as well. It's not something which is to be taken lightly of. So, meaning what I mean is, so they serve huge amounts of content at a rapid pace to huge amounts of people, and the only way you can actually do it, and the only way you can go about scaling such things is only if you have the right architecture in place. So we are going to discuss about the Netflix architecture today, so stick around. So what I will be doing is I will be actually referring some of the links which are already posted by Netflix. So unlike other organizations, Netflix is a bit open, so meaning they share all the architecture which they use. They share all the principles which they use. They share everything behind their engineering openly with the community, and they have their own open source projects as well. So we will actually have a look at how Netflix actually works, and not just that, we will also see some of their open source projects which drives their engineering or infrastructure. So that's what we are going to talk about today. So let's get to it. So, in case you have any questions, comments, feedback, suggestions, let me know in the comments. So I'll reply then at that. So yeah, so I have a huge amount of information to share with you today. So this is all the links I have. So we'll actually have a look at it. So before I go on and share more details about Netflix, so if you don't know what Netflix is, it's a organization which it's a company like Amazon Prime or Geo Video in case you are in India. So Geo Cinema. So they share TV and cinema content. They stream content live to a lot of audiences. I don't want to talk about Netflix now, but rather the engineering behind Netflix. So Netflix is highly architecture driven, engineering driven. They are highly microservices driven. So the reason of Netflix adopting a microservice architecture is to make engineering teams develop at a rapid pace to avoid a single point of failure, and also the fact that they have to scale to a large extent. So since they are serving a lot of content to a lot of people at a rapid pace, so the only way you can do it is if you have a scalable architecture, which is something which microservices architecture actually provides you with. So that's something which Netflix actually does. So the entire architecture is based on microservices. So that's one thing to keep in mind. So the cloud provider of their choice is AWS. So in case you just Google it, Netflix is completely based off AWS. So initially they were based out of their own data center, but then they had a failure of service for 3 days. So 3 days they were not able to serve content to all their users. So what they did is they made the switch to using a cloud provider because they didn't want to spend time in managing the cloud infrastructure by themselves, but rather use a cloud provider who is already an expert in doing that and rather focus on the product at hand. So that's what Netflix actually did, and they moved on to AWS. So that's where they host all their videos, content, and everything. And yeah, so in case you have seen AWS, so they have something called as S3, AWS S3. So that's what they use to store all their videos. So let's quickly open up our diagram interface to you know, plot the architecture of Netflix. So let's quickly do that. So this is my factory season 1. So I hope you're able to see my screen. So we are going to plot the Netflix architecture right from the start. So we are going to walk you through how and why Netflix made such decisions. So here is the user who is going to access the Netflix application. So let me make everything small because we have a lot of things to cover. So and here is the Netflix application, and the user is going to access the Netflix application. That's what is going to happen, right? So now the Netflix application is going to be served through the AWS data centers which they have cloud data. So their entire infrastructure is hosted on AWS. So let me just put AWS here. So okay. So all the microservices, all the servers, all the containers, all the virtual machines they have is completely based on AWS. So yeah, that's AWS for you. And first point of entry. So the user is going to enter Netflix, right? So the first point of entry is going to be through a Netflix-driven software called Zoom. So I'll talk about that. So before that, so it's a gateway. So it's also inside AWS. So it's not outside. Sorry. So it's a gateway which acts as the single entry point, Zool 2 to be exact. So this is an API gateway made by Netflix themselves, and it is distributed gateway. So which means that you can you can scale this gateway across multiple clusters. So multiple nodes or multiple instances. So that way you can actually have repeatability and fault tolerance. So that if one gateway fails, your entire infrastructure is not going to fail. So and here you have a load balancer. So if you have AWS, you have the load balancer provided by AWS itself and the gateway provided by AWS Route 53. So if you want to have a look at Route 53, you might actually want to go through AWS. So there is Route 53 here. This is the way to easily route. It's a software-based load balancer. So it's not hardware-based. So it's a software-based load balancer, which means that in case you change anything, you don't have to, what do you say, worry about redeploying applications, changing things and everything. So software-based load balancer from AWS. So all the traffic enters the AWS load balancer from the user. So irrespective of where the user is located, it enters the load balancer, and they have a gateway which serves all the requests. So this is Netflix. So let me do one thing. So Netflix actually has. Okay, let me close this box. Okay, we have a lot of area to or so Netflix actually has a lot of content to be delivered, and most of it is media. So you don't want to see, the video buffering when you are, let's say the video is hosted on US and you are in India. You are trying to see a video which is hosted in the US data center from India. You are going to face a lot of lag because it takes some time for the video to travel to your location. So they leverage CDN so that the content is stored, synced to the location which is closest to the user. So they have their own CDN. I think it is called Open Connect, if I remember correctly. CDN from Netflix, which is from Netflix themselves. So I'll show you how it looks like. So they have a CDN called Open Connect. So what this does is, so if a user is going to access, let's say, content in US from India. So first important thing is it will actually sync all the content from US into the CDN. I mean, the frequently accessed content from US will be synced to the CDN, so that, I mean, CDN is nothing but a part of infrastructure where you can actually host content at the edge. What I mean by edge is you have the users who are accessing from India, right? So which means that the user is going to hit the load balancer. I mean, this is going to provide an anycast IP. So which means that there will be one IP for irrespective of where they are located. So this is going to be any cache load balancer, and this load balancer is going to refer the CDN if the user is going to access a content in US from India, which means that it will deliver the applications much more faster than before. So that's something. So we have a CDN here. We will talk about this Open Connect and everything. So and Netflix does all their communication through GraphQL. So that's what they do. They have a GraphQL interface here. So that's where all the calls coming from various clients they have. So they have a web client, they have a mobile app client, they have they have a Netflix TV app, and they have more, right? So all the content is served via GraphQL to all the apps. So now, yeah, so we talked about this, and this authentication which takes place and everything. So and Netflix has a lot of microservices. In fact, I might be wrong to say it is thousands. I don't know how much they have, but the entire architecture is based on microservices. So they have multiple small microservices inside the infrastructure. And okay, so and they don't use Kubernetes, they don't use Swarm, but rather they have their own container orchestration platform called Titus. So that's what they use, and they have Titus here to orchestrate all these microservices. So okay, where do I put Titus here? Okay, let me put it here for now. So Titus is for container orchestration. This is built by Netflix themselves because the time Netflix started off building the orchestration platform or started looking for some container orchestration engines. So Kubernetes was not as mature as it is today. So they went for building their own. So that's what they did. Titus container orchestration. So yeah, so GraphQL is going to hit the microservices based on, okay, let me put Titus here. So this would be the right place to put Titus because you have to do service discovery and Titus will handle all of that, and then finally your request will come. Come on. I hate aligning these boxes with arrows and everything. Anyways, So we have Titus, we have the microservices, and each and every part of Netflix infrastructure is powered by microservices, which means that they have media service for what do you say, fetching all the media. They have a payment service for fetching, for doing all the payments and subscriptions, for handling all of that. They have a payment service, and they have what do you say, a service for just fetching the metadata. So they have metadata service, and they have a lot of services like these. So it would be nonsense to talk about services now today, but rather we will talk about the infrastructure behind those services. So one thing which we talked about is Netflix uses S3 for all the storage. So all the media content from Netflix is stored in AWS S3. So they don't manage their own storage, but rather they use S3. So you might be wondering, why do I need CDN and S3 as well? So S3 is used for permanent storage, and CDN doesn't have permanent content, which means that like as soon as the TTL or expiry goes beyond a time limit, as soon as you see the traffic dropping for a video, that content would be cleared from the CDN. But S3 would have that media permanently. So this S3 is going to be used as storage engine for all their media. So yeah, the database which they use for all their storage is Cassandra. So Cassandra is what they use. So it's a NoSQL based distributed storage. So if you have a look at Cassandra quickly, so it's from Apache. It's open source. It's really powerful. It can scale to massive extent. It can store massive amounts of data without like what do you say, without losing any data. So you can distribute it across multiple nodes, multiple servers. You have fault tolerance in place. It is decentralized, scalable. So it's really good, but it involves a lot of maintenance, because you have to handle huge amounts of infrastructure, and unless you have huge team to manage all this, it will be difficult. But it's really powerful. So it's used by a lot of people. So Cassandra is what they use. Yeah, it's used by Activision, Apple, Bazaar, Best Buy, Sun. So you can already see why it's powerful, and Netflix is right here. So Netflix is how Netflix manages petabyte scale using Cassandra and cloud. So that's what they use. They use Cassandra for all their storage. So yeah, we don't want to see Cassandra now. We'll take it some other day. But yeah, so S3 for storage and Cassandra for the database. They use NoSQL data. So all the data is stored as NoSQL. Just a moment. Yeah. Sorry. They use a mixture of Cassandra and NoSQL. I mean, Cassandra for storage, and they use a NoSQL storage as well. So I'm not sure of what database they use for NoSQL, but anyways, they have a lot of services behind the scenes. So this is the microservice layer from Netflix. So we will put a dabba around it. Ouch! I can't do this. I can do it only if I have layers, right? Okay, now mind. Forget the dabba. So we have media payment and metadata. So which are going to be the microservices, and there are going to be other microservices as well. Like you have a service for account, you have services for geolocations and everything. So and in fact they have services for A/B testing as well. So in fact Netflix does a lot of A/B testing, like because they are delivering and shipping at a rapid pace. They want to be testing things rapidly with users to see if things are working out properly or not. So they have amazing A/B testing frameworks. So let's quickly look at some of the reference links from Netflix. So first thing is okay, what happens when you click the play button? So this is a blog where they say what happens when you click on play. So if you see the Netflix architecture, so this is like the entire infrastructure of Netflix. You have it in a single flow diagram. So you can already see how much infrastructure they use, how much distributed or clumsy it is. So anyways,
So yeah, here at a glance, hundreds of microservices, thousands of production changes and everything. So he has given a quick stats which says how large is Netflix. And as we talked about, Netflix is based on AWS. They store it on S3. They do transporting on EC2, which means that every video once you upload, once a provider uploads it, you have to process it. You have to transport it into multiple